Hello, everybody. This is the next lecture of Unit 2. And so we just completed the stuff about central limit theorem and sort of the mathematical aspects of central limit theorem, how it relates to our ability to do research. But now we're going to kind of get a little bit more specific. So the last one is a little bit more conceptual, although we tried to tackle it through an actual example. But now we're going to get into actually doing the research. So central limit theorem says we can do research. Now, since it says go ahead and do the research, now how do we do research? So there's actually kind of two parts of this lecture that are intertwined. And those parts are the basics of research methodology. So we have to get some terms down. We kind of have to understand research to be able to understand statistics. But also we're going to get into the first part of hypothesis testing. So there's going to be a second part that I'm going to do after this lecture in a different lecture. But we're going to start looking at some aspects of hypothesis testing. So remember, inferential statistics is testing hypotheses. Obviously, that's why we do research. We don't do research just to get descriptive statistics, usually. We do research because we want to test hypotheses. So there's very specific ways that we do it and how we approach it in statistics, so I need to teach you that. So let's just start generally. So let's think about beer goggles. So what is this? And so usually when I ask this in class, people say, oh, well, it's glasses you put on, it makes you see things like you're drunk. Well, that may be true, but that's not what we're talking about in this class. In this class, we're talking about people who say, oh, why did you hook up with that person? Oh, I was drunk. So, the idea that people are better looking when you are drunk. So let's state a scientific prediction about this. So pause and see if you can do a scientific prediction. Okay, so hopefully you stated it some way. And I think the best way to say is the more alcohol that you consume, the more attractive you think other people are. So more alcohol you consume, the more attractive you think other people are. And so I also ask here, do you think this is true? You can answer this for yourself. Typically in my classes, I hear people say that they believe that this is true. We are going to, hopefully I'll remember to talk about this at the end. I will tell you what the research says. But before I tell you about that, let's just go through what we're supposed to do. So we have a prediction. The more alcohol you drink, the more attractive you think other people are going to be. So in statistics, we talk about different types of hypotheses. There's an alternative hypothesis and there is a null hypothesis. The alternative hypothesis is what we typically think about when we talk about hypotheses. So what I just stated just now, the more alcohol you drink, the more attractive you think other people are. That's an alternative hypothesis. Why is it called alternative hypothesis? Well, that's the effect that you think is there. Alcohol increases your perception of attraction. Why is it called alternative hypothesis? Because that's not what we're testing. If you know the philosophy of science, you can't prove anything. And so since we can't prove anything, we can't really test this. We have to test the negation of this. What's the negation? The negation is the bottom there, the null hypothesis, that alcohol does not affect your attraction to other people. So the null hypothesis is that alcohol does not affect your attraction towards others. So a null hypothesis that there is no effect is what we test in our statistics. And so basically we test if there's no effect, and if we have evidence that we can reject that null hypothesis, then we can say that we can make a conclusion that there is some effect for alcohol. I know it sounds a little bit weird, it sounds a little bit convoluted, but it's just because we cannot prove anything in science, and so we have to set up a null hypothesis to hopefully reject, and if we reject the null hypothesis, we reject that there's no effect, then we have some evidence that there is an effect. That's the nature of science. So again, the null hypothesis is what we're testing in our statistics. Okay, let's think about this then. So we have to test our hypothesis, so we have to do a study. And again, we're thinking about this beer goggles thing. And so let's think about an experiment at first. So what's an experiment? So I'm hoping that you say something like an experiment is, well, you might do it in a lab, but a big thing is that you're manipulating something, right? So in an experiment, the researcher manipulates stuff and then see how it affects things. So I want you to think about, and just ignore that in pairs. This is stuff I would do in class in pairs, but you would do it by yourself, or if you want to bring in somebody who's in your house and have them come and do this with you, that's fine with me. So, you know, either yourself or with somebody you grab in your house, design an experiment to test the beer goggles hypothesis. Remember, the beer goggles hypothesis was the more beer you drink, or sorry, the more alcohol you drink, the more attractive you think other people are. So how would you do this experiment? So be specific. How would you do this experiment to test out the beer goggles? More alcohol, more attracted to other people. And after you do your design of your experiment, state what your hypotheses are. So remember, your hypotheses are alternative hypothesis, and there's also a null hypothesis. Go ahead and pause the video and go ahead and do this. So hopefully you've done this on your own. So, you know, some examples that would come up in class include these things. And so hopefully many people should say that it's in a lab. So you probably want to do this stuff in a lab. Why? Because you don't want a lot of other stuff happening that you can't control. So experiments are often done in labs because you can control the whole environment. And the only thing that you're differing, in this case, should be the alcohol. So you should be manipulating the alcohol. I don't think I have this here, but don't do this experiment. I'm going to write it because I feel like I should write it. So I don't get sued. Do not do in real life. So we're just talking about this. We are not going to do this because it's full of a bunch of unethical or possible ethical issues. I should say unethical. People have done these experiments, but they've done it with research board reviews and with ethical guidelines. So do not do in real life. So hopefully you said that you do this in something like a lab where you can control everything. The only thing that you're manipulating is the alcohol. So you're giving people alcohol because that's part of your hypothesis, right? More alcohol that's consumed, the more attractive people are going to be to each other. So one way that people often design this is that they might set up different groups. So you might have one group that doesn't drink alcohol and another one that does drink alcohol. So typically the studies that I would hear that people would talk about in class, they would bring in people and then they would have hopefully a placebo group. So you know that people, if they think that they're drinking alcohol, they're going to act differently, right? So just like a placebo for medicine, we probably want a placebo group where people think they're drinking alcohol, but there's really no alcohol. So if they think somehow, oh, if you're drunk, you think you're getting drunk, you should act this way. We should control for that. So we should have a placebo group because we really want to know whether it's the alcohol or whether people think, oh, this is what drunk people are supposed to do. So we can have a placebo group, and it's important for the placebo, actually for both groups, for everybody that walks into our study, we should ask them, have you drank anything within the last 24 hours? their answer should be no. If it's not no, you say, see you later, you can't participate. So you might make sure that they don't have alcohol in their system coming in. And then for half your people, half the subjects, you would have them drink fake alcohol. And for the other half, you would give them some drinks. It could be a certain number of drinks. It could be 4 shots, or it could be 6 shots. So you might have one group that gets drunk or has alcohol, and another group has placebo. And then you would have them do some attraction ratings. So you have to have some sort of attraction rating. So remember, one thing is the alcohol. So you're manipulating that. So one group, no alcohol, the other group has alcohol. You're manipulating that. You're systematically changing that. Then we have the attraction rating. So remember, that's part of our hypothesis. More alcohol, more attraction. So we have to do that somehow. Maybe a real simple way of doing that here is we can have photographs. So we can have photographs, and there's a bunch of people, and everybody in this study is supposed to rate the attraction of the people. And so each person comes in, we either give them a placebo or we give them drinks. We wait for a while because we want them to have the alcohol seep in, or they think they're getting drunk in the placebo group. Then after whatever it is, 20 minutes, we'll give them the photos, and we'll say for each photo, rate your attraction to this person from 1 to 10, with 10 being the most attraction. So you get them to rate all those photos, and then you'll have for each person an average attraction rating. And then you'll have for each group. So there's a bunch of people in the placebo group. You'll have an average level of attraction for that group. And then you'll have the drunk group, and you'll have the average level of attraction for that group. And then you'll compare those two groups on their levels of attraction to other people, to the photos. And basically, if the beer goggles hypothesis is correct, your drunk group would have higher ratings of attraction versus the placebo group. So you're comparing two groups. You're comparing the drunk group with the placebo group. And you can have more than two groups. So you can have the placebo group and, let's say, 2 shots, 4 shots, and 6 shots. So you can have different levels, they call it, of the study. So it's really up to you in terms of the experimenter, how many groups you want to contrast. So that's one design. And notice that every person in your study is in one group, but not in both the groups. You're either in the placebo group or you're in the drunk group. That's a common design. Also, students come up with the last design here. So in this design, the people come in. You ask them, have you drank in the last 24 hours? They say no. Say, okay, sit down. Here's some photos. Rate the photos. So you're having them do the 0 drinks. They're rating the photos right away. If you want to make us the placebo group, you can do that. It's up to you. So you can give them fake alcohol at first, if you want to. But basically, they have had no alcohol. And then they rate the attraction of the photos. Then you give them 2 drinks. You wait for a little bit. You say, hey, here's some more photos. Can you rate the attraction of these photos? So they rate the attraction of those photos. And then you have them drink 2 more drinks. So now they have 4 drinks in their system. You wait for a little bit of time. Here's some photos. Rate their attraction. So it's the same people, but here the levels are 0 drinks, 2 drinks, 4 drinks. Each person experiences that. Each person experiences each of those levels of drinks, and each of those levels, they rate the photographs. So you have a rating, an average rating. I shouldn't say average. You have a rating for each person for 0 drinks, 2 drinks, and 4 drinks. Then the question becomes, when you look at everybody's score, does their attraction increase with more alcohol? So now the question is, within people, within each person, do their ratings increase from 0 to 2, and then 2 to 4 drinks? So these are common designs that students come up with in terms of the research, the experiments. So let's actually take these examples that are very common. And my guess is that if you did this, you had something that was one of these two things, probably. And so let's look at some terms now. We've done the study, and we're going to reinforce some of the stuff that we talked about earlier in this class. So what's dependent variable? So DV, dependent variable. Well, the dependent variable is the outcome. The outcome was attraction. So the question was, does alcohol affect attraction? So the thing being affected, the outcome was alcohol. So the DV was alcohol. This was an experiment, so we had an IV, an independent variable. The independent variable that we were manipulating to see if it changed behavior was alcohol. We gave people more or less alcohol. So the thing that we manipulated to see if it affected something, the IV was alcohol. Then we had different levels. So levels are different conditions or different alcohol levels that we had. So we could have 0 drinks. We can have 2 drinks. We can have 4 drinks. That is 3 levels. If we did that first study, we would have to have 3 groups because we have a group that has 0 drinks. We have a group that has 2 drinks. We have a group that has 4 drinks. So we have 3 levels. We'd have to have 3 groups in that first design. In this second design, where we have everybody having all the levels of the alcohol, each person would have to have 0 drinks, 2 drinks, and 4 drinks. So levels is, in this case, we can see it's just the number of drinks that people have. So we call that conditions in experimental design. You can have more if you wanted to. So if you had 0 drinks, 2 drinks, 4 drinks, 6 drinks, then you have 4 levels. Or if you had 0 drinks versus 4 drinks, you have only 2 levels. So it's really up to the researcher to decide what makes sense in terms of what the levels are and specifically how much to give to people at each level. I keep on checking this because I'm paranoid because I don't want this thing to turn off on me. We already discussed the difference between a control group or a placebo group. Control group is the person's not drinking alcohol. They know they don't have anything. That's a control group. A placebo group is they think they're drinking alcohol. Again, placebo group is important when the person has some sort of expectations about what's happening. So in this case, I think it's good to have a placebo group because people have expectations that if you're drinking, you're going to act in a certain way. Drunk people act a certain way. So a placebo group would be good in this design. So both of these, whether it's a control group, but again, the control group, the person knows they're not in the treatment group. Treatment is the alcohol. Treatment is what you're giving the people, the IV that you're manipulating. So whether it's a control group or a placebo group, they're your baseline. What type of attraction, what level of attraction do people have to other people when there's no alcohol involved? It's the baseline. So we need that baseline to see if our treatment is the stuff we're giving people to see if they change behavior. So in this case, it's the alcohol. Seeing if the treatment of alcohol changes people's level of attraction. And then there's a term that we have with experiments that's called internal validity. What does that mean? So if we have this sort of IV of the alcohol and we want to see if it affects the DV of attraction, nothing else should be changing. So we should have what we call experimental control. So the room should be the same for both, all conditions, all levels. Our experimenter should be acting the same. So everything should be the same for everybody, every level of alcohol. And the only thing that differs is the actual alcohol. Why is that? Well, let's say that the experimenter knows that this person's drinking alcohol. They might just act in a weird way that Like, here's some photos for you to rate versus here's some photos for you to rate. If you say it differently, you might be transmitting your expectations to the participants in your study. So if you act differently with different people and things change in the experiment with different people, then you don't know what's going on. Maybe it's the alcohol that's changing people's attraction levels, but maybe it's something else that's going on. So you want everything to be the exact same for everybody. The only thing that's differing is the alcohol. Why? Because if other things are differing, maybe those other things are changing the behavior. So now you don't know what's changing the behaviors. It might not be your IV. This is called internal validity. If you have control and nothing else is varying except for your IV, then we say that you have a very internally valid experiment. So we talked about things that are actually extraneous variables. So extraneous variables are things that can change the person's behavior. That's not the IV, so things that aren't the alcohol. So if by some weird reason you have a different type of room for the two types of levels, let's say a placebo group versus the 2 drinks group or 4 drinks group, if the room that you're using is different for those different groups, that's a bad thing. It could be the room that's making people act differently. And so you don't want other things varying. So extraneous variables means that other things are varying besides the IV, and it's a problem because they might be changing the person's behavior, might be changing the attraction ratings, and it's not the alcohol. So there's a type of extraneous variable called participant variables. So participant variables are things that somebody brings in to the study, and that can affect their attraction ratings. So it could be something about the person. So what I like to talk about in terms of the attraction, and we'll have actually a lot of attraction sort of studies that we'll talk about as examples throughout the course. So let's say that we are talking about attraction ratings. We just know from experience, right, that people differ. Our friends, as we probably know, some friends that we have are very picky. Everybody's a 2 or a 3. There's rarely even a 5. They're very picky about it. And then we might have friends who are not picky. Like everybody's an 8 and 9. That's fantastic. Or a 10, Everybody's really cute. So they're not picky. And then probably a lot of us are in the middle. We're kind of in the middle. We're not really picky or not picky. We're kind of in the middle. So this is something that people bring. They bring in their pickiness into the study. And we don't want their pickiness to affect our results. We'll talk about this in a second. There's other things that can affect it too that people bring in. So let's say that you are driving, it starts pouring rain, you get a flat tire. Let's say that you have to fix that flat tire, you have to go out, you're soaked, you walk to the experiment, and you're really angry. You're all wet, and you're frustrated, and the world is hideous. Is that going to affect your attraction ratings? Probably. Let's say that it's another day, and it's a nice sunny day, and you're skipping around, and the bunnies are hopping around your feet, and just the world is fantastic. You go into the study. Is it going to affect your attraction ratings? Well, probably. And there's tons of other things. So let's say that you just broke up with your boyfriend or girlfriend. You walk into this study. Is that going to affect your attraction ratings? Probably. Let's just think that you just met somebody and you're just smitten with them and you're just so in love. I got smitten from, I think, the Howard Stern show. Somebody was talking about whether they've ever been smitten by somebody. I just like that word. So you're smitten. You come into the study. Is it going to affect your attraction ratings? Probably. So there's all these things that people bring into the study that can affect the findings. So what do? We have to make sure that these things are equalized, and we're going to talk about groups. So this is really important when we have different groups of people. So for example, we have a placebo group of people, and then we have a 4 drinks group of people. So they're separate people. We're comparing their attraction scores. We don't want stuff that the participants bringing into the study to affect those differences. And so what do we do? So one thing we do is random assignment. So we talked about random sampling earlier. Random sampling was we have a population, and everybody in the population has an equal chance of being selected into our study. Random assignment is similar, but in this case, it's about assigning people to conditions, to groups. So if we have a 0-drink group, a placebo group, and we have a 4-drink group, everybody who comes into our study, they have a 50% chance of being in the placebo group and a 50% chance of being in the 4-drink group. So people are randomly assigned to their group. If our groups are large enough, random assignment should equalize all of these participant variables. So random assignment, if our groups are big enough, the pickiness level should be equal across our groups. The bad day versus good day should be equal across our groups. The breakup to finding a new love that we're smitten with, that should be equalized between the two groups randomly. And so the level of pickiness is the same between the two groups. Therefore, pickiness should not affect the attraction scores, the average for the two groups. It shouldn't come into play. So if there's a difference between the 4-drink group and the placebo group, it should be because of the drinks. It's not because of anything that people brought into the study. Even better is a technique called matching. What do we do with matching? We say, well, there might be something. We can't do this for all the variables, so I said that there's many things, and it's true, there's lots of things that you can have an effect on the study. But let's say there's one thing that we really know is, and let's say it's pickiness. Say, hey, wait a second, we know that some people are really picky and some aren't. This could really affect our study. So can we measure this? Yes, we can. Maybe we can be really clever and we can have them do it before they come into the study. So we send them a link, and in this link we have them rate 10 photos. So they go to the link and they rate 10 photos and we record it. And then we can actually see how picky people are. So we have people who are really picky. They have really low scores. Well, half those picky people, we put them in the placebo group. The other half we'll put in the 4-drink group. Then we have not picky people. They have really high scores, so we'll put half of them in the placebo group. We'll put half in the 4-drink group. So now we've measured the thing that we know could affect our DV, the attraction ratings, and we systematically make sure they're equalized, they're matched across our two groups. So that's what matching is. You measure something that you know that is really going to affect the DV, and then you make sure that they are equalized between the two groups. So you have an equal number of picky, not picky in both your groups. The word confound, what does that mean? Confound means that there's something that changes exactly with the IV level. So a very common thing that's a confound is that if you have poorly trained experimenters and they act differently to your different groups. So let's say that there's this experiment. So we have the placebo group and we have the 4-drink group. If we have a really poorly trained experimenter, if they know that, they might act differently. They might act different towards the 4-drink group versus the 0-drink group. And how they act towards them is going to affect their attraction ratings. This is a confound. Why is it a confound? Because it varies exactly with the IV. If you act different with the 4-drink group versus the people who are in the placebo, that behavior of yours that's different is exactly changing with the IV of 4 drinks versus placebo. Big problem. It's a big problem because a confound, if that's happening with your IV, it could be that behavior. It could be that thing that's changing people's ratings. It could maybe not be the alcohol. It's because you're acting totally different with the different groups. So confounds are especially bad in experimental designs. So what we just talked about, actually, that example I gave of a confound is what's called the expectancy effect. So if you know that somebody's in the 4-drink group versus a placebo group, you expect different behavior from them. And if somehow your expectations gets transmitted to the people, they're going to act differently because you expect them to act differently. Something you did made them act differently. So a good design in experiments is what's called double blind. Double blind means that this participant doesn't know whether they're in the placebo group or 4-drink group. And also the experimenter running the study doesn't know it either. So if you don't know if that's actual alcohol or not, you should not be acting differently to the people because you don't know what condition they're in. Then I think this is the final thing that I want to talk about, and this thing is really important in terms of our class. In terms of experimental designs, we have between subject designs and we have within subject designs. What does that mean? I'm going to go back to our, whoops, why is that doing that if I'm going up? I am going up. So this first example is this one group versus another, the 4-drink group versus the placebo group. This is between subjects. So if we say between subjects design, it means that each participant gets just one level of the IV. In this example, each participant is either getting 4 drinks and is in the 4-drink group, or they're getting placebo, they're getting fake alcohol. So they're in one group or the other. So between subjects, you get just one level of the IV and you're comparing separate groups of people. And no person is in more than one group. So you're comparing separate groups of people who get different levels of alcohol. The bottom one here is called within subjects design. What's within subjects design? Within subjects design says everybody in your study gets all levels of the IV. So in this case, everybody gets 0 drinks, 2 drinks, and 4 drinks. And within subjects, you're comparing within people. So within each person, do they increase their attraction ratings with the more alcohol that they drink? So within subjects is everybody gets all levels of the IV. Everybody gets 0, 2, and 4 drinks. And you're just comparing people within themselves, whether they change their behavior 0 versus 2 versus 4 drinks. So that's the basic difference between subjects and within subjects design. We are going to talk about this quite a bit throughout most of the semester because we do different statistics for these different designs. So this is just our first foray into that terminology. So we have our data now. So we did our study, right? So we did our experiment. Now how do we approach this statistically? So statistically, we always have to go through 5 steps. And I'm going to have you specify these steps for everything that we're going to be doing until the next exam. So for this unit, I want you to specify each of these steps, and we're going to cover these in the next 3 lectures that we have. So what's step 1? We have to state our HO and HA. So our HO, again, is that alcohol does not affect attraction, but we're going to be more specific. So I'm going to go back to this thing, and I'm going to write on this, but I'm going to erase it. So remember that we have, actually I'm going to bring this up into a Word document. I'm going to make this easier. So here we have, let's say we have 2 groups. We have 4 drinks versus placebo. So let's take that design first. So we have 4 drinks versus 0 drinks, and I don't know why I can't see my thing. It's way over there. That's annoying. We'll bring it out here. So let's just take that example. So our HA, usually we'll start with our HA. So that's what we expect to find. That's why we're doing our study. So if we think that the beer goggles is correct, we can say that the 4 drinks group is going to be greater than the placebo group. Well, on what? Well, on their attraction. So this is our HA. Now it's gone. Just ignore that 2 over there. Again, I'm going to be paranoid. It's still recording. So our alternative hypothesis, what we actually think is going to happen if we believe in the beer goggles effect. 4 drinks group is going to be greater than the placebo group on what? On attraction. That's our HA. Our HO will be, there's no difference. So we would actually state it this way. The 4 drinks group will be equal to the placebo group on what? On attraction. So here we state the HA and the HO. HA is our alternative hypothesis. HO is the null hypothesis that we'll actually be testing with our stats. Let's take the other example since we're here. So we have the within subjects design where everybody's getting 0, 2, and 4 drinks. So that one is 4 drinks greater than 2 drinks greater than 0 drinks. On what? On attraction. So within people, they should have higher attraction ratings at 4 drinks versus 2, and that should be higher than when they had 0 drinks. So what's the HO? I'm going to save some time. What is the HO? The null hypothesis. Null hypothesis says there's no effect going on. So the null hypothesis would be these conditions are equal. So when we look within people, their attraction ratings are not going to differ regardless of whether they have 4, 2, or 0. It's going to be the same. So this is what we mean by stating the HO and HA. We just simply state it this way. Don't worry if you're not quite getting this. We're going to be doing this a lot. This is just our first run at it. So that's our first step. Our second, or sort of our little subnote here, it says one tail versus two tail. So I'm going to show you what I mean by that with our little statements. I've given you a one tail because I think that's the preferable way for social sciences, but there might be some debate about that, which is fine. What's a one tail? One tail is when we say that we're going to make a prediction, one's greater than another. So by just simply saying the 4 drinks group is greater than a placebo group, I made a one tail prediction. And I have a feeling I'm going to want to draw this. What does that mean? I'm going to draw that real quickly. And so give me a second. I'm going to make this big because I think I'm going to draw both one tail and two tails here. So this is a one tail. What does tail mean? Because you kind of get the whole thing about greater than. So one tail means, well, let's draw our normal curves. We're going to be having a lot of normal curves in this class. So this is a mean. And we'll start very simply here is we're going to have this be the placebo. So the mean is the without treatment, so there's no alcohol. So there's the mean there. What does one tail mean? One tail means that we say that the mean for our treatment group, so this is 4 drinks, remember? 4 drinks, we're saying it's greater than. That's why we're saying it's one tail. We're saying that our alcohol group is going to be in this direction of being greater than, being higher on attraction ratings than the placebo group. So we're only caring about it whether it's in this tail. Two tail, which we will not do in this class, but we should know it because a lot of people think we should do it this way, but I think not. So we have the same normal curve, and we have the same thing here. We have a mean of the placebo group. I'm going to make it simpler. We'll just say a mean of a placebo group in this case. A two-tail says, well, we don't know. Maybe attraction ratings will decrease with alcohol, or maybe they will increase. So it could be over here, or it could be over here. All we care about is whether it's different from this. So is it different from the placebo? Yes, and we don't care whether it's lower or higher. That's two-tail. I think in later lectures I get into why one-tail is better, I think, and so I'm going to neglect that now. I just want to sort of say what one-tail and two-tail is. So one-tail, you make a prediction in one direction. It's going to be greater. Two-tail says, well, it's just going to be different from the placebo, and we just don't know if it's lower or higher. It's just different. That's what the tails refer to. So we made actually one-tail predictions, and I'll show you again, because we said greater than. We said that's greater than, and we said greater than, greater than. So we predicted a direction. That's one tail. Okay, step number 2 is we need a rule. So we need a rule about, well, when is this really something that we should pay attention to? When is there really an effect? And so this rule is actually based on the probabilities of the normal curve, but we can think about this graphically. I'm going to draw this again. So here we go. We have our study. And I'm going to try to make this as broad as possible, but let's see. And so we're kind of making an estimate of our population mean. So this is a population distribution of people's attraction. So, you know, a lot of people are around average attraction, right? So most people are sort of average, and the average is here, and there's fewer people who are really not picky. So this is high scores on attraction. So there's fewer people who are not picky with really high scores on how attractive they find other people. And there's also a few people who are very picky, who have really low scores for people. So our placebo group, remember this is our placebo group. They don't get alcohol. They think they're drinking alcohol. Their mean would be around here. They'd be around the population, just how people on average are attracted to other people because they haven't had any alcohol, so there's no treatment there. So now the question is, in terms of setting this criteria, how far here does our treatment group need to be? What if I told you that our treatment group, this is the 4 drinks, what if the 4 drinks group was here? Is this a big enough difference to say that the alcohol had an effect? I'm hoping you're saying, I'm not sure. Remember, we could actually graph this out as a z-score, and I'm guessing maybe that would be around 80th percentile, maybe 75th percentile, around there. You know, is that far enough to say there's an effect? I hope you say, I'm not sure. I don't know if that's far enough. But what if our treatment group was way over here? Our 4 drinks attraction ratings were this far away. Were this much higher than the placebo group's attraction ratings. I hope now you're starting to say, well, maybe there's something there now. It's really far. The score's a lot higher. And if we remember our z-tables, we're way over here. Let's be ambitious and say that there's only 5% of people's scores over here. Let's say there's only 5% of scores over here. So now there's only a 5% chance, just due to dumb luck, the sampling error, that our treatment group would be this far, would be this high in attraction. There's only a 5% chance that this is just dumb luck, that it's sampling error. What does that mean? There's a 95% chance that something happened with the alcohol, that there's an effect. So if we have, sorry about this. So if we have our 4-drink group, if their scores were so high, and if there's only a 5% chance that they would be that high just due to chance, when we look at the normal curve, there's only 5% of the scores over here. That means there's a 95% chance that the alcohol had an impact because we're so far this way. So this is what we're talking about in step number 2. In step number 2, we're setting a criteria about how far we have to be off there on the right-hand side of the normal curve to say that there's something going on with the alcohol. So that's what we're doing in step number 2. And here you actually see that it actually says likely and unlikely. So it's very unlikely that we would be this far to the right, correct? If we had means of the 4-drink group over here, or over here, or over here, or over here, this is pretty likely because there's a lot of scores there in the middle. So if our alcohol group was over here, and it's likely they would have that mean of that level, then we'd say, well, then we can't really say that alcohol has an effect because it's just there's a high probability that there'd be scores around there. So it doesn't really look like anything's happening. If you're way over here, it's unlikely. How unlikely is it? There's 5% or less chance it's just due to luck. So it's unlikely. So the criteria that we want to set is we want to say that something's unlikely due to chance. Because if it's unlikely due to chance, if there's less than 5% chance it's just due to luck, there's a 95% chance it's due to our IV. It's due to the alcohol. This is what we actually call alpha, and we'll talk about this more, so if you don't quite get this right now, it's okay. What's the alpha? Alpha, it's this. Our alpha is the percent that we say that if it's due to luck. So 5% due to luck, this is our alpha. This is our line. So if the mean of our treatment group's over here, it doesn't cross the line, our alpha says then there's not an effect of alcohol. It's probably due to luck. But if we put a 5% chance for our alpha and our treatment group's over here, then it's unlikely, then we have evidence for an effect. And in psychology, we actually set this mark for our alpha. Our alpha is that there's a 5% chance, it's due to luck, it's due to sampling error. We can live with that, but if it crosses that line and we're over here, then we say that the alcohol had an effect. So that's step number 2. I need a little quick break, but you won't see it because I'm going to pause. Okay, so that's our second step. So basically in science, we have to play a fair game. And part of the fair game is that we need to say, well, when are we going to say that we're wrong? Our alternative hypothesis is not supported. It looks like the thing that we thought had an effect doesn't really have an effect. So we have to set that rule early in the game because we can't change it later. So you set it beforehand. What's step number 3? So you collect your data. So you set the rules before you collect your data. You say what your hypotheses are. You set the rule for the alpha, so how far down the normal curve do you have to be to say that that's unlikely due to chance? It's probably due to our IV. You have to set these rules before you collect the data. You can't collect your data and then start setting the rules. That's not fair because you're going to make up different rules to try to find something in your data. So you set the rules first. Then you collect the data and you compute your statistics. So obviously the computing statistics we're going to talk about. We'll actually have a first little example in this lecture in a bit. So you collect your data, compute your statistics, and again, you always collect the data after your hypotheses are stated. You always collect your data after you set your rules about the alpha, how far down the normal curve you have to be to say it's unlikely. And again, you do this because that's an objective way of doing it. It's called a priori. So if you ever hear the word a priori, you set the rules before you look at your data. Step number 4. Once you have your statistics, you're going to make a decision about the HO. Remember, we're testing the HO, the null hypothesis. We're testing that hypothesis that there's no effect of the IV. And again, we just kind of went through that. So that little line I drew, that little 5% line I drew, that's the line. So again, if we had a mean of our treatment group, the 4 drinks group, that didn't cross that line, it wasn't far enough away from the placebo mean, then we have to say that there's no effect. That's actually what we would call this second one here, fail to reject the HO. So if we had something, if our mean was not crossing that line, it's too close to the placebo group mean. We don't have evidence for an effect, it's not far enough away. The way that we state that decision is that we say we fail to reject the HO. Why do we say fail to reject the HO? Because we can't prove anything in science. So we just say that we failed to reject it. But let's say we have that line again, way off to the right, that 5% line. If our mean is far enough, if it crosses that line, it's far enough away from the placebo mean, then we have evidence for an effect, right? We cross that 5% line. It's unlikely due to chance. There's only a 5% chance it's due to sampling error. There's a 95% it's due to alcohol because it's so far off to the right. If we have that, if we have evidence for an effect, we say that we reject the HO. So we're rejecting the null hypothesis, which means we're rejecting the idea that there is no effect. I know it sounds weird to say it that way, but we're rejecting the idea that there's no effect, which means that we have some support that there is an effect. So that's what we're doing with step 4. We're making a decision about the HO, and we say it in this way. Again, if you're not quite getting this now, we are going to do this a lot in this class, so you'll catch on pretty soon. So remember that we were saying that, there's only a 5% chance that it would be so far right, so far away from the placebo mean, that it would be due to chance, and therefore there's a 95% chance it's probably due to our IV, to alcohol. These types of statements is called statistical significance. So if I say that there's only a 5% chance or less that we'd have a mean attraction for the 4 drink group that was so much higher than the mean for the placebo group, then we say that there's statistical significance. What's the significance? There's less than a 5% chance it's just due to dumb luck. There's a 95% chance it's due to the alcohol. So that word statistical significance, we're going to be talking about that, but that's basically what we're talking about. We've already had that drawn up, and that's what that is. Then step number 5 is we write up our findings in plain language. So again, we are going to do this in all the stuff that we're going to be working on in this class. So let's take another approach to the beer goggles. Let's say that we are going to study it in the real world. And this will be pretty quick, because I think we've covered major concepts, but I just want you to get this part of it. Let's say we're going to study it in the real world. And the rules are you can interact with people. So you can give them stuff, you can give them questions, you can give them photos, but you can't give them any drinks. So remember that in a non-experimental study done in the real world, you can't manipulate the alcohol, so you can't give them any drinks. And again, you can't do the study in real life. So how would you do the study? So again, design a quick study about how you would do this. So if you're like a lot of my previous students, you probably would say, well, let's go to some place where people are drinking and where people are hooking up or interested in hooking up. So let's go to a bar or maybe a party. So you would do probably a couple things. So you need a measurement of the DV. So one way that you can measure the DV is you could actually have them rate other people. So you could say, look at those other people in the bar or in the party. For each person, rate their attraction level. So you could do that. That might be a bit messy. So, and you might actually get somebody punching you, perhaps, as they're being rated. You know, what are you doing over there? Or you could just bring the photos. So here's some photos, rate the photos, how attractive is each person, da da da. So we have a measurement of the DV, and we also have to measure our predictor variable. So remember, we're not manipulating anything. We're watching something in real life. So people are in real life drinking, and some people drink a lot, some people drink a little. So it's a predictor variable. It's a PV. So we measure our predictor variable, how much are people drinking. We can ask them or we can watch them. And we're going to correlate how much they've been drinking with their attraction ratings of the photos, for example. So we could do that design. That'd be like a correlational design. And we could see, you know, if people who drink more, do they give higher attraction ratings, or people who drink less give less? We could also do another design. It's a little bit more complicated, but they could walk in the door. We could ask them if they drink. They'd be really perfect if they haven't drank that night yet. Then we have them rate the photos, and we let them go, and they go into the party. We watch them. We see that they take 5 drinks. We go up to them and say, hey, do you mind rating these other photos for me? Well, how attractive do you find these photos? You watch them some more, and they take some more drinks. You ask them to do the ratings again. So this is similar to that within subjects design, except we're not manipulating how much they drink. We just watch how much they drink. And as they drink more, we ask them to do more ratings of the photos to see if they change in their ratings as they drink more throughout the night. So just real quickly, we'll run through this. So this is non-experimental. Why is it non-experimental? Because we aren't manipulating any variable. We are not giving them any drinks. And so it's called non-experimental. We're not manipulating, we're not giving them drinks. We're just watching them drink. So in this case, in non-experimental studies, we talk about external validity. So remember in experiments, we talked about internal validity. Internal validity had to do with whether you controlled other variables. So nothing else is varying except for the alcohol that you're giving them. So here, we don't care about that because obviously we are not giving people alcohol in this type of study. But we care about what's called external validity. Why is this externally valid? It's externally valid because it's like the real world. We went to bars and people are looking at each other and seeing if they can pick up somebody or hook up with somebody. And we go to parties and people are drinking there and they're going there, some of the people at least, maybe to hook up. And so it's externally valid. It's something that's real world. We study people in real world. It's real world behavior of drinking. It's real world of attraction, looking at people and whether they're physically attracted to them or not. And in general, external validity is traded off with internal validity. So think about our lab study, our lab experiment. We could have a very internally valid study, but it's so artificial. You know, they're sitting in a lab, they're looking at photographs, there's no real people there, there's no chance they will hook up with anybody. And so it might not be really the most real world situation. So it might be really great in terms of its internal validity, but its external validity is horrible. It's so artificial. But then look at our non-experimental study. So it's real world. We're going to where people drink naturally and where people are naturally checking out other people and thinking about how attractive they are. So it's real, it has high external validity, but there's 1,000 things going on. The music's changing, there's people coming and going in the bar, there's a ton of things we can't control. And so it's got a lot of external validity, but it has a horrible degree of internal validity. So many things are happening that we can't control that could be affecting the DV, the ratings of attraction. So in general, there's a trade-off between those two. So we've already talked about that the alcohol in this case is a predictor variable. We do care about whether the PV affects the DV, so does alcohol affect attraction? We care about that. But with predictor variables, we are not manipulating the alcohol. We're just watching people do it just naturally how they do it. We aren't changing their behavior. We have different types of design. We have post-only and we have pre and post design. Post-only is this first one. So we go up to people and say, how much have you been drinking tonight? Rate these photos. That's after they've been drinking. That's post-only. The second design, the one on the bottom, is pre and post. They walk into the bar or the party and say, have you drank tonight? Nope. Great. Rate these photos. That's the pre-treatment, pre-alcohol level of their attraction. Then they drink. We go up to them and say, now, can you rate these photos, please? So it's after the treatment, after they drink, post. So we have a measure of pre, before the treatment, before alcohol, their attraction. And we have post, after they drank alcohol. So that bottom one is a pre-post design. And that's a stronger design, obviously, because we do have a baseline. We have the level of attraction that people have before they drink and then after. And it can be multi-method. So I put multi-method here. So we didn't talk a lot about because we can have different methodologies. So even on both things. So for the predictor variable, we have different methodologies. We could ask people how much they drink. We could watch how much they drink. We could take their blood alcohol level. This would be a little bit unethical, but let's just say we could do it. We can take their blood alcohol content level. So there's different ways we can measure the PV. There's also different ways we can do the attraction ratings. We could have them rate the photos. We could have them rate real people. We could have them rate real people. Maybe we'll have Confederates working for us, and they're there, and we could say, there's 5 people. They actually are with me, so don't worry. You can rate them, and they won't punch you in the face. Or we could just have them rate the real patrons or the real partygoers. So there's different ways that we can rate these things. So typically in non-experimental methodologies, we often think about different ways we can measure our predictor variable and different ways we can measure our dependent variable. That's called multi-method. So if we have different ways of measuring the variables that we're curious about. So these are terms that you should know in terms of non-experimental studies. So we have the same thing here. We have the same steps. We have state the HA and state the HO. So they're a little bit different here in terms of our different designs. So I'm going to actually write this out. That's my blank that I want to keep. So I'm going to change the HO and HA here. So the first one, remember the first one we said we're just going to go up to people, how much have you drank, and rate these photos. So we just get a bunch of people. Some people have drank more that night, some have less. And we see if just these people that drink more or less, if those variables correlate with each other. So the amount of drinks that people had, does it correlate with how much they rated in terms of the attraction? So this HA would be that increase. So more alcohol, more alcohol that somebody drank, they would have higher ratings of attraction. This would be our HA. Because we're just correlating 2 variables here. The HO is, I'm just going to state it this way, no effect on attraction. So there's no correlation. We could also say that. So we could say that, we'll get to this very late in the course, but this is a positive correlation. There's a positive correlation between alcohol and attraction. So the more you have of alcohol, the higher your attraction ratings. And this would just say that there's no correlation. So alcohol does not have an effect. And then let me go to the other one. So let's say that we do this other one. Actually, it's the same. Yeah, I like this one. It's easier. So let's say we do this one. So they walk in the door. And remember, we're not giving them drinks, so we're not systematically manipulating. So they come in the door, have you drink? Nope. Do the pre-ratings. Drink some. We're going to come up to you. Rate these photos again, please. Or different photos, probably. Then they drink a little bit more. We find them and say, oh, you're still here. Can you rate these photos? And so this is also the same thing. But we would do the analysis slightly different, but the hypothesis is the same. So within each person, the more they drink, they had higher attraction ratings. And we'll call it correlation because we're not manipulating systematically what they're drinking or how much they're drinking. And then the HO is alcohol didn't have an effect. So the more they drank, they didn't change their attraction ratings. So the HO and HA look like that. For our, I'm going to cancel that. I might want to use this later. Or maybe not. So that's our first step. Our first step is always HO, HA. And notice that we had one tail. More alcohol, more attraction. So we have a direction. A two-tail would be alcohol affects attraction. But we don't know if it's a negative effect or a positive effect. But one tail, I think, is nicer. Step 2, so we have those rules. So I drew that earlier, so we'll use the same rule. I think the comparison of groups is a little bit clearer, so I don't want to work things up. I think that the thing that I drew for step number 2, for the experimental goal, look at that if you don't remember it. That was pretty good, I think. Step 3 is the same. We're going to collect our data. We're going to compute our statistics. Step 4 is the same. We're going to make a decision about the HO. And step 5, we're going to put in words. So we're going to get into this more a lot later, but just to let you know, we're just going to express it in words, the findings. So if alcohol increased attraction, we want to say that. Alcohol produced increased attraction ratings. We just say that in normal words. Then we would say what the statistic is that we use. We haven't done any statistics yet for inferential, so we'll get to that later. We want to say what the significance level is. So remember that the p is less than 0.05, that we're going to talk a lot about in this class, means that the finding we found, the effect of alcohol that we found, is less than a 5% chance that it's due to just dumb luck. So there's less than a 5% chance that if we say that there's an effect, it's due to luck. It's actually probably 95% sure it's due to the alcohol. And then we say what the exact relationship is. So positive, more alcohol, higher attractions. Negative, more alcohol, less attraction, or no correlation. Or we say the groups differ. So the 4 drinks group had higher ratings of attraction compared to the placebo group. And then we give our statistical numbers. So the nice thing is when we do our write-ups, we actually start with human being language, and then we give our statistics after that. And again, we're going to do this a lot in this class. This just introduces this. We're going to have a lot of examples coming up in lectures. So we're going to have a part 2 on hypothesis testing. So just to help us with that transition to part number 2 on hypothesis testing, which will be a separate video, a separate lecture. And we've already seen this in what we did today. So there's 2 basic types of hypotheses. One type is the groups differ. So it can be often in experiments. So it could be the group that had 4 drinks had higher attraction ratings than the group that had no drinks, the placebo group. Sometimes we can do that with PVs, but I don't think that's a great approach. So, for example, let's say that you're curious about whether introverts and extroverts act differently. And so you could take a measurement and give people a questionnaire measuring introversion, extroversion, and you can split the sample with a median and say that if you're above the median, you are extroverted. If you're below, you're introverted. And then you compare those two groups, the extroverts versus introverts. You can do that approach with a predictor variable. It's not great. Why is it not great? It doesn't really capture the variable. In reality, half of us aren't extroverted and half of us are introverted. That's not the reality. The reality of the situation is that people differ. Some of us are really extroverted, some of us are really introverted. So the reality is that people differ on a continuum. So why I say this is not a great approach, saying extrovert versus introvert, is because that's not the nature of personality. So our methodology and our statistics should capture the nature of the thing, really. Okay, let's get to the second type of hypothesis. That's the relationship between two variables. So this thing that we just did with the non-experimental method, where we said the more alcohol led to more attraction, that is a relationship between two variables hypothesis. More alcohol, higher attraction. So remember that, our samples are from a population, but our sample can never represent our population. Therefore, our inferential tests are always about probability. So you notice that we say that there's only a 5% chance that there'd be such a high mean of attraction for the 4-drink group versus the placebo group. There's only a 5% chance it's due to luck to be so high. To be so far away from the placebo group, there's only a 5% chance that that would happen due to luck. Therefore, it's 95% chance it's due to the alcohol. So inferential tests are all about probability. So there's always a chance that we can make an error. So, if we say that there's a 5% chance error, that the treatment group, the 5-drink group, would be so far from the placebo group in terms of attraction ratings, there is still a 5% chance that that's due to just chance, due to dumb luck. So that's also an error. So if we say there's a difference there, we know that there's a possibility, a 5% chance, that it could just be due to luck. It's not due to the alcohol. So that's an error in hypothesis testing. So errors are possible. So there's two types of errors that you need to know in statistics. There's one that's called type 1 error, and we just talked about that. Type 1 error is we say, hey, alcohol has an effect, but it doesn't. So in statistical language, we're rejecting a null hypothesis, but it's actually true that there's no effect for alcohol. So I call this a false positive. So false positive is we say there's an effect when there isn't. Oh, hey, alcohol increases attraction. Well, nope. There's a chance you made a type 1 error. You're running around saying alcohol has an effect, but it really doesn't. False positive. What's nice is we know exactly our probability of a type 1 error. It's our alpha. So remember, I drew the normal curve and I said, well, we know that there's only a 5% chance to have scores way far off to the right. Our alpha is 0.05. Our alpha is 5%. We set that. So if we get a mean for the 4-drink group and it's way far over there, and we say it's different from the placebo group, there's a 5% chance that we're saying alcohol had an effect, but it really didn't. So we know the probability of type 1 errors in our studies, and we set that beforehand. We set an acceptable level of a type 1 error. Type 2 error is the other major type where we do the opposite. We say, oh boy, no, the 4-drink group didn't score that much higher than the placebo group. It's not far enough. It didn't cross that line of 5%. And we say there's nothing going on. So in this case, let's say that alcohol actually has an effect on our population, but we missed it in our study. That's a false negative. So we say, alcohol didn't have an effect, but really in our population it does. That's a false negative. We say there's nothing going on, but really there's something going on with our population. So in statistical terms, it's that first thing there. We fail to reject a null hypothesis that is really false. That's very convoluted, right? So what it's saying is that there is an effect, so the null hypothesis is actually false, but you didn't reject it because the numbers weren't far enough on the right to do that. I'm much more comfortable if you say false negative. You probably are also. So false negative, you just missed an effect that's really there. Something's going on in your population, but your sample didn't show it. This is harder to identify. Type 2, the probability of this is we don't know. We don't know what the percent of that is, but that's okay. And actually what you do is you change your alpha level based on what kind of study you do. In psychology, we pretty much stick to the 0.05. But let's say that I'm studying cancer, and there's a new treatment for cancer, and it's so radical. It's so different than what we've done before. Well, I might start off with a very high alpha. So I might say, well, let's have an alpha of 20%. Because I don't want to miss something. I don't want to miss an effect that's there. And so I do my first study on this treatment. And I say the alpha will be 20 because I don't want to miss if this really works. So I set it at 20% and I find an effect and I say, okay, fine. But then when I do my next study, I better change the alpha because now I better be more rigorous because I need to be sure it's happening. So my first study, I put it at 20% because I didn't want to miss something. I didn't want a false negative. I didn't want to say the treatment doesn't work when it really did. But maybe the next study, I'll set the alpha at 10%. So I run the study again and I find an effect. I say, okay, well, I have a little bit more evidence that it works now. I made sure I didn't miss it. I had that 20% to start with. I didn't miss it. I did a 10%. Still says something's going on. I better be sure. I'll change it to 5%. I do the study again, another study, and I see if I have evidence for it then. So, if you have something that could really help people, maybe your initial studies will have a bigger alpha because you don't want a false negative. You do the study and you say, oh, nothing's happening, and you give up. And you throw something down the drain that could help people's lives. So my point here is that we can actually set our alphas to guard against false negatives if we do certain types of research. For, typical basic scientific research, you better be at a 0.05 level or below that, 5% chance. But if you're studying something that can change people's lives, and maybe it's something that's so new, you don't have any data on it, maybe you better broaden that possibility of a type 1 error to 20% because you don't want to miss something that could actually help people. So when you do research, you actually have to think about these issues. So statistics is not something that people should do blindly, but you should do with some thought. And that's it. So that is our first lecture, our first part of hypothesis testing. And then we will have a second part to hypothesis testing. And that part will also deal with our first inferential statistic that we will actually calculate. So I will talk to you then.